Alright, CAD Challenge people. It's March 27th, Friday, and we're going to talk through some file formats here. I got nobody in the chat room to ask questions here, unlike the last one. That's okay. I'll hopefully get all the information to you because we have a folder and it's got a few things in there. Most of them are stuff that I've uploaded, and I want to show you a few different file formats that'll actually work pretty well, whether you're 3D printing parts or whether you're trying to actually share this with somebody so that they can use it. Now, just so you know, I've got a couple things up here on screen. I've got my example phone holder, which is a file that has a whole bunch of stuff in it. It's got the phone holder itself, it's got an example phone, it's got a bar. You'll notice that I've actually got I've got my phone as two components right now. That was an error, but we can merge those as we go through here. I've also got Nate's battery holder, so thank you, Nate, for uploading something. This was the raw STL file, and talking to Nate on Discord, I think this came out of SolidWorks. We're going to talk about STL files a little bit here and a few things we can do with them, and go from there. Now, if you're working in Fusion to start, the basics of what we are doing here is trying to create this battery, this phone holder, sorry, apologize, and trying to get it to somebody so that they can use it. And communication is half the battle. It's actually a good portion of what I teach in my class is how to communicate engineering design. So the question you have to ask yourself is, what are you communicating? Do you want somebody to look at your file and just know the basic uses for it? Do you want to have it so that they can print it? Do you want to have it so that they can actually modify the file itself? And those are the kind of the three file formats we're going to go through. So to start, we're going to work with 3D printing and the idea of an STL file or something that's 3D printer compatible. Now, in Fusion, this is relatively easy to do. We just simply go up to our menu here, file menu, and we go to the 3D print button. It's going to convert a section of our object into a mesh body. And you see I'm going to click here, and I believe since I've got two components, I'm just going to select them and make sure that I've got both of them. There we go. And those two components are now going to be sent to the 3D printing file. You'll notice when I check off a few things here, I can preview the mesh, and what it'll show me is that it's actually creating some polygons in here. It's actually converting this to a single shape file that it's then going to actually be able to send out to a 3D printer, for example. I like high refinement. I have no reason to keep my file sizes particularly small, especially for something simple like this. If you're 3D printing a very complex part or something where it didn't matter exactly where all the edges were, you may want to change that down. For my output, I am going to uncheck the Send to 3D Printer utility because I don't really want to use this right now. I have other tools that we can work with on our 3D printer to make this happen. Once I've done this, I can go ahead and I can save it. I'm going to save it as a good descriptive name, 7277 Way Phone Holder. Puts your team number in there, puts your name in there, and it puts a good description of the part you're doing. This is going to come off as an STL file, and again, those are really good for especially the hobbyist grade 3D printers. If you're working on any of the Creality ones, the Prusas, those kind of things, they're really good. That's a good file format for you to get those over with. Now that I've got that out of here, we can see what an STL file looks like. And now when I created that STL file, I just took the plastic that I wanted to print. I'm going to go over to Nate's battery holder. And Nate, I apologize if if any of this criticism, if you take it personally, but I'm just going to point out a couple things that we could do better with this one, and hopefully you can export these so that other teams can use this absolutely beautiful battery holder. So Nate's put the battery holder together, and what you can see is that this has come off as a mesh file, and it's a very nice mesh file. Like I said, I actually really like this one. And there's two things that aren't really working here. The first is that this all came out as a single file. So similar to what I had here, this would be as if I'd exported this with the bar and the phone attached. They're really good for measuring things too, especially when you're working with any CAD formats. But in the case of this, it's something where we wanted to probably have a main body for this battery holder. We probably wanted to have a bottom plate for the battery holder, a couple bolts to hold it all together, and then the battery itself. Now, when you exported the STL file, it all came out all together. So the way I can look at this as well when I'm 3D printing is if you go to your Inspect tab, there is the option here to actually do a section analysis. I love section analyses, especially for 3D printing. So I'm just going to do a section analysis along this plane, and I can actually cut in and see, yep, he's got the whole battery in there, and yeah, I can actually see the entire mesh all the way through here. This is really good for finding things like overhangs and stuff when you're trying to 3D print. It's very effective. Now, once I've done that, I can actually see the inside section here. I'm going to look for a couple of things that I would do differently here on this one. The first is I would actually take and export this as separate STL files so that I could print each one individually. But if I wanted to reverse engineer this, I would actually want a different file format, which is going to lead us back to our phone holder here. And if I wanted to send this phone holder, you'll notice that my timeline at the bottom here shows the whole process I went through to actually build this thing. And it actually is really really useful sometimes to reverse engineer. Let's say I wanted to go back through the process as to, how I'd built this, take the team numbers off, modify some of the chamfers on the back here, for example. Go back and see where it was colored, where we added pieces, etc., etc. If I wanted to reverse engineer this, this is a really, really good thing to have. Now, to get this file format onto somebody else's computer, there's a few ways you can do it. You could actually just share the file straight up with another person. You could share your entire folder with another person. But one of the easiest ways to have it archived somewhere is to export it as a .f3z file. This is going to give it the basic Fusion 360 format. I know SolidWorks has a similar format that you could also send it in, and this is actually going to allow people to see the entire creation of the object and potentially modify individual pieces of it. So if you feel like your work needs to be remixed or modified, this is a really good format to go with. Now, the last format that I actually want to talk about is it's one of my favorite ones, especially as a teacher. I like students presenting this in class because in Alberta we do have some CTS credits directly associated with technical design and technical drafting. So let's take a look here and let's actually turn this phone holder into a technical design. How I'm going to do this is I'm going to go up to my File menu and I'm going to create a new drawing. And I'm going to make the drawing to come in from a design because I'm in the design right now. And what you're going to see is I'm actually going to get a little menu over here that says, what drawing do you want to do it from, okay? In this case, I want to use reference the full assembly here. I'm going to modify a few things with that, but I'm going to bring the whole assembly across, okay? I'm going to make the template from scratch. If you wanted to create a title block template, say you were working for a particular engineering firm or you want to create a team template, that's kind of a cool project to work on. But for right now, I'm just going to go from scratch. I'm going to create a new drawing. I'm going to use the ISO standards and A3 paper. If you wanted to mess around and dimension things in imperial or metric, you can absolutely do that here. Once you've done that, you're going to press OK, and this is going to take a second. It does take a minute to load this all into a new drawing. Pull that up, and here we go. We have a brand new untitled drawing. I do recommend that you save your drawings as quickly as you can, just so that you don't lose any data. And from there, we're going to have some stuff we can do here. Now, a couple things you'll notice. First thing is that the title block automatically appears. At this moment, it's going to say it's sheet 1 of 1. It's going to give you the title based off of the actual drawing that you've started this on. It's going to tell you your name based on your user account and the date, which is super useful because I don't have to put all that stuff in manually. You'll notice that I've got a side view of my object here floating around. I'm just going to pin it to my page. I can move it around as I need to, but I'm going to go over to my drawing view menu here, and I'm going to play around with a few things. So you'll notice the first thing you see is that there is an orientation button. And if I wanted to start with, let's say, an isometric view, I might turn this around to get one of my isometric views. I'm going to start with northeast for this one, isometric. Now, you'll notice that right now I have visible edges checked off. I can check off hidden edges, shaded, or shaded with hidden edges. I'm going to pump the scale up a bit here to make sure we can see this. So right now it's at a 1:5 scale, and it's obviously pretty small. I'm going to pop this up to a 1:1 scale. And I'm just actually quickly going to just click OK. And what you're going to see is that this is going to create the drawing. And there's going to be a little grip point right in the middle that's going to let me drag it into the middle of my screen because this is perhaps what I want to show. I'm going to mess around with a few things here though. First of all, I'm going to double click on this. And if I want to see hidden edges, let's say I have a complex piece of machinery, I can actually put hidden edges on. And sometimes that's useful. In this case, maybe not so much. I'm just going to make my phone and my bar go away because realistically, this is the battery holder I have. I'm just going to zoom in a little bit to show you how disorienting this is right now. So you see the hidden edges, they don't really help me at all in communicating the shape of this object. Some objects they do. For this one, I'm just going to go shaded. You also have the option of doing visible with hidden edges. This creates a wireframe version of it with no coloring, and you can create just visible edges. This is pretty common in engineering drawing, something like this. If any of you assemble IKEA furniture, it's going to start to look very, very familiar. Okay, I recommend not messing with the edge visibility for the most part on this, but there's a few things you can do in there. Now, based off of this, I have a few options, and for this drawing, I'm just going to show the front and back view to show the overall version of, or view of what this is. And what I'm going to do is I'm going to go up to my drawing, and I have a choice. I can either create a projection based off of this drawing already, and it's going to kind of guess at the angle for isometric that I want. As you can see, if I click here, right click, and then press OK, I actually get a really weird angle on this. I don't like that very much for communicating what I'm trying to do, so I'm actually going to create a brand new base. Now this brand new vase, I'm gonna have to go through the same steps I did before. I'm gonna have to change it to isometric. Press OK, and you'll notice that it's showing up in my browser over here, where I can actually get different parts to show up. I can actually do the same thing I did before and just make the small parts I based everything off of invisible, and I can actually show this here. Now, just to finish off the effect, I'm just going to go ahead and insert an image here, because I'm a bit of a stickler for this one, and I like putting logos on things. I'm just going to zoom this in a little bit and drop my school's logo right here. Scale it down to about, I don't know, 0.6, somewhere in there. Not quite there, 0.5 I guess. And then just quickly slide it over to place. That's the AutoCAD. Clicking you here is the AutoCADer in me that is trying to type in commands and have them work. All right, cool. So now that I've got that, that's a pretty good place to start. It's going to show an overall view of kind of what I'm looking at. But if I want to be a little more technical with this, I'm actually going to go down to the bottom here and I'm going to add a new page. And you'll notice the new page, it shows up. It shows page 2 of 2, and when I go back to my first page, I now have page 1 of 2. I can add a few other things on here that for most robotics applications, for most first applications, aren't all that important. But this next view is going to let me actually do a few different things. So I'm going to go for the new base view. I'm going to click here, and I'm going to actually make it a right-hand side view so that I can see the front of my phone holder. I'm going to pop this up to, I think 1 to 2 is probably best. Probably go 2.5. Nope, sorry, 1.5. And I'm going to press enter. Okay, on this one I'm just going to do visible edges because I just really want to see the wireframe. Same thing as before, I'm just going to make the rest of my parts in here invisible so I can just see the part that I'm working with, and now I'm going to use the projected view. Projected view is going to let me show, for example, a side view, for example, a top view. I really don't need a second side view. This is what we call orthogonal or orthographic drawing, and if I have symmetrical edges, or I have things that are going to look exactly the same from multiple aspects, I really don't need them. So at this point, I probably have a drawing that I can work with. If I want to throw an isometric view in here, I can also do that. In this case, I think I'm going to skip that chance and just simply put this as is. To do that, I right-click and I press OK. There's my drawing. Now, I have a few options here which are kind of cool. I actually have the option if I, for example, need a center mark for machining stuff, I can do that. I can put center lines in. I can actually do a whole bunch of things with the geometry. But the thing I really want for this is potentially some dimensions. If you want a reference dimension to know how tall this is, you can actually snap a dimension on here. Now again, in this case we're talking about metric, I believe, based on my settings. And we can actually dimension specific things on this drawing. This is really important if you're having parts machined, for example. If they're not coming off a CNC machine, they probably need to have dimensions on them, so whoever's making them knows how to fabricate them. At Nelson Mandela, we deal with this all the time because a lot of our parts get made up in the aviation shop, so we send them to students, and they're very used to the notation on this. Now, one of the other things you can do that I actually find hugely useful is putting leaders on. And if you look at this drawing in our folder, you can actually see that this is something that I've made use of. Where you can actually show and communicate things to people who are potentially looking at your drawing and actually point at things such as this is the cutout for the phone USB. This is where you point out the features that you've actually designed into your particular object, into your particular drawing. Now, when you are done with these drawings, and you can add as many pages as you want to this booklet. In a very complex machine, let's say a robot, you might have dozens of pages showing each individual piece, showing subsystems perhaps. If anybody wants to see some very cool versions of this and some pieces of these subsystems go together, the technical binders for Team 254 and FRC are usually legendary. They are actually very well put together. Anyways, this is going to allow us, and I'm just going to quickly go over and grab my logo here, which I'm realizing is now not quite centered, but that's okay. I'm just going to grab a copy, and I'm going to paste it in here. Oh, I have to drag a new one in. That's okay. I'm going to leave that for right now, and we'll move on with things. Okay, the last thing on this is how do you actually present this? Now, in this case, it's right on your front screen. I would definitely go with this is an output as a PDF. Reason for PDF, portable document format, is this is going to be easily accessible and easily viewable on every platform. People's phones, computers, Macs, Linux, doesn't matter what you're running, PDF is the way to go. As an aside, if you're sending a resume, PDF's a really good way to go as well. They're just very ubiquitous. They work everywhere. At this point, I have the choice. I could do current sheets. I can select sheets. I'm going to go all sheets because I only have 2. I can keep the line weights, and I can open my PDF somewhere if when I'm done, so I can actually see it. But regardless, I'm going to press OK and ask where we're going to go. I'm going to save this as 7277 away phone holder. Press OK. And what you're going to have now is a PDF document pop up. And it's going to show you those 2 pages that you just created. Now, the reason for communicating things this way, this isn't printable, but if somebody's looking for a quick overview of what it is you've created, this is the best way to do it, because somebody can pop this up and they can know right away what the technical specifications are on this thing that you have created. In some cases, and here's an example of this, I've actually got this saved in R. I'm just going to hop over to Discord for a moment, our usual Discord chat, and I'm going to go into our actual CAD folder here. There we go. And we can see that we've got a bunch of files here, but when I click on these as PDFs, it's really easy to see exactly what's gone on in this particular drawing, how the part works, how it goes together, and in some cases, if it's a multi-part assembly, like this battery holder, how it's actually assembled. This is going to show you where pieces go and how they fit together more or less. So that's the overview of the ways to communicate things using using Fusion. And remember that you're communicating things for a specific audience. So none of these are necessarily the best way. There's no one single way that you're going to communicate your designs. For some applications, the PDF blueprint form is going to be by far the easiest. For some people, they just want to see it in STL so they can plonk it into their 3D printer. And in some cases, especially if you're trying to learn this stuff, you want that .f3z file so that you can actually reverse engineer, or you can learn from the actual process of how somebody built something in CAD. Hope that was helpful. If you have any questions, throw them in the Discord. Cheers.